Hi there, my name is Reshu. I welcome you all to my channel. I'm very glad that you all are here to learn more about data science. Today I'm gonna teach you about a very important step, data wrangling. What is data wrangling? Data wrangling, which is also called as data munching, is a very important process in which we transform the raw data into a usable form, which contains the valuable meaning for it to be assessed. So here are the project details. The tasks in this project are as follows. Data wrangling, which consists of these steps: gathering data, assessing data, cleaning data, storing, analyzing, and visualizing the wrangled data. Reporting on these data wrangling efforts and data analysis and visualizations. Loading data. Import the important libraries. Import pandas, numpy, request, tweepy, res, json, time, warnings. These are just used for accessing the data using the Twitter API. So we have three forms of data. The first is in the CSV form, which we are directly reading as in a pandas data frame. Now second is image predictions, which is actually in the form of URL. So this URL is getting written as image predictions.tsv and then further read as a pandas data frame here. Basic difference between this one and this one, you can see that this is the CSV comma separated and this is TSV that is tab separated. So that is why we have used the separator /t. Third type of data which we are gathering from is Twitter API and JSON. We are using these two, that's why I have named it like this. So the aim is here to query the Twitter API for each tweet in the Twitter archive and save the JSON in a text file. These are the hidden complies which can be accessed using your Twitter developer account. Like this is my Twitter developer account and there are my two apps. First one is Twitter app, which I created like very time ago, and this one is the one which is based on the recent project, the project we are analyzing, that is dog project. The details can be accessed here. We have app details here, keys and tokens. I'm not going to open this because this contains two secret keys. Permissions, read and write permissions I have given to it. Okay, so the consumer key, consumer secret, access token, access secret, these four things can be accessed from this key and token panel. Save the each tweet's return JSON as a new line in a .txt file. So this is actually saving the tweet's returned JSON as a new line in a .txt file. Now what is happening is that whatever is in this tweet, we are getting tweet mode is extended, and then tweet ID is saved as tweet ID, retweet count is saved as retweet count, and then favorite count as favorite count. These are all dumped into a JSON folder and out file. This is the output file format that is in the JSON. Except, try and except, which is a Python parameter. So try and except block, which is used to handle exceptions. The try and except block in Python is used to catch and handle exceptions. Python executes code following the try statement as a normal part of the program. There's a try, there's an except. For try, whatever is written under the try, you have to run that. For except, whatever is written therein, you have to execute this code when there is an exception. I have commented this because this takes about 20 to 30 minutes to happen, and if I uncomment this and run it, it will again repeat the process. So I just, after downloading the JSON file, I just commented this whole program. Now reading the text file line by line to create a data frame. Whatever we had saved in the form of .txt, now we have to read it in the form of data frame. So that is what we are doing here. Okay, reduce the df API to the necessary columns. Now we need to reduce it to the necessary columns. Actually, this is our data frame, and from the df API, which where we had saved this, we are using only 3 columns, right? ID, retweet count, favorite count, which is like where we are going to focus. So like DF JSON head is here. We see this is the ID, retweet count, favorite count. Now let's assess. In assessment, what we do is that we inspect the data set for 2 things: the data quality issues and the lack of tidiness, that is the structural issues. So we will be assessing all the 3 data, that is the Twitter archive, by looking into its tail, by looking into its head, like which type of data it is, what is we can improve on, make it more accessible. We are doing the programmatic inspection of the Twitter archive, where Twitter arc.info, it gives us the data types and the number of elements of each type. So this we can see, this is of int type, float, this is object, float. Memory usage is also provided here. Now we are describing it. The describe function gives us count, mean, standard, 25%, max and min. So now we just check for the duplicacy. For the duplicacy, we use the sum function here. Twitter arc, there is no duplicacy, so it gives the output 0. In the Twitter arc, if we see the sources and their value counts, we have 1, 2, 3, 4 sources basically, and the first one has most value counts, 2, 2, 2, 1. Now we are analyzing the Twitter arc and assessing the Twitter arc rating denominator value counts. In 64 it is. Check if there are any records in the Twitter arc which are retweets. We have used this thing to check that, and we found out that 181 records are there which are actually retweets. Let's sort by rating denominator values using the sort index. Let's sort by rating numerator values using the sort index. Observations. Basically what we observed. The ID variables are sometimes integers or floats. In reply to and retweeted, state variables are numeric. In reply to, okay, this one. And retweeted status. These need to be numeric, but they are actually float. So we need to, actually numeric, float is obviously numeric. Source values are formatted. Okay, so if we remove these things, we can analyze it better way. Rating numerators are not always correctly accounting for decimals. Dog names are not standardized, obviously. Structure, that is tidiness, more than one stage is filled for a particular dog. Source and expanded URLs have several informations inside them. Columns, doggo, floofer, pupper refer to the same measurement, that is dog stage. What we see here is that we don't need to have 3 separate columns for doggo, floofer, pupper, pappu. We can have one with the dog status, for all of 1, 2, 3, 4. Now visual inspection of the image prediction. Image predictions, visual inspection, if we have a tweet ID, JPG URL, image number, P1, P2, P3 conf, P3 dog. Let's assess its head, its tail, its shape. Shape gives the number of rows, number of columns. Image predictions.info, the data types of each, the memory usage. Let's see duplications. No duplication here, 0. yeah, in case of image dot prediction dot duplicated, but in case of the URLs we have 66 duplicated numbers. In image number we have one of one type 17802.198.366 and 431, and the data type is int64. Let's see the observations here. Quality is tweet ID are numeric and not categorical. Column names can be improved. Yes, they can be, because they are a bit confusing actually. P1, P2 and P3 contains underscores instead of spaces in the labels. Yes, there are underscores actually. JSON file. Visual inspection of the JSON file. Here we have only ID, retweet count and the favorite count. Assessing head and tail and info. And then describe. We found out that for the duplication 0. Number of missing IDs actually. You can see how many missing IDs are there. 2356 minus 2338. Which accounts for 18. The number of missing IDs is 18. Let's assume they have been deleted. The errors during API data download. Actually here it is 2354, right? This is 2356 and this is 2338. I don't know what it is. Probably just ignore this, because at some point of time I might have found I have had done this before also, and that would have been 56 obviously, and this 2338 would have been there. Okay, let me just see what is happening here. There are this much entries actually, but in in the description we had 2 3. You need to have 2 3 5 4 actually. This is 2. This need to be 2 2. Let's come to the cleaning process. Try to resolve the issues. Let's prepare a working copy of each separate dataset. Why we are preparing a working copy of each separate dataset? Because what happens is that when you are dealing with the data, and by mistake also, if you lose the part of data, you will not be able to rewind it, like redo it or undo it. So what happens? To be on the safer side, we make a copy of it and then perform our analysis or whatever techniques we are going to perform on that. So Twitter R copy, I have created dot copy here for prediction 1. This is named as prediction 1 for the image prediction dot copy. Dev JSON 1, dev JSON dot copy. Okay, yeah. So this dot copy is used to create the copy of each. Twitter archive, let's define. In this we are defining the unique values. So here we have this unique values we are getting, such a, quite, not, one, incredibly mad, and these are actually the unique values here. Data type is object. what is happening is that in this there might be some, you know, repeating things, like this one you see, this one you see. These are some, you know, assessing issues. But in case of unique, you are not having such issues. So these faulty things, actually the, by, a, not, one, these are getting removed out of our this column. Wherever these things are present, we are removing them. We have tried to remove them. And here's the result. There isn't such a thing. Let's define. Assign 10 to rating denominator column values. Rating is 10. Convert the time step columns to date. So whatever is in timestamp has been converted to date time format. Date time format. Let's test whether we have been able to convert it or not. And let's just check it. Yes, we have been. Now this has been converted to date time format. Define, create the dog stage column by combining the columns Togo Flu for Pupper and Papu in the same. So we are converting all of these in a one column. So that's what we have done. Appended everything into one column named dog stage. Let's check whether it's been performed successfully or not. And we see a dog stage that's combined. Everything has been combined into one. Okay, so let's count the number of values for Pupper, 245. For NA, that is none, that is most, that is 1976. That's why we are seeing here, you know, in the first 3 or 4, only none. There are some cases where we have a Duggo plus Fluffer, that's 1. Duggo plus Papu, that is 1. Now coming on to the another issue, capitalize the first letters of P1, P2, P3, which is not necessary, but you know, I just tried it. So so you can see here Welsh, Redbone, these have been converted to W is converted to the caps 1, okay. It's not necessary, but it just looks good. So you can see here in the prediction 1, which is the copy one, we have everything in caps, while in the former one we have this R in small letter. Replace this and this symbol with spaces in P1, P2 and P3. So we are using dot replace, dot str dot replace these into this and this into this in P1, P2 and P3. Let's see we are able to achieve it or not. P1, this is P2. Yes, we have been able to achieve. Like there you can see there is no underscore and no dashes, while in this one, in the former one, you can see there were, like you can see here, there were the underscores and dashes. Tweet, retweet and favorite counts. Set the tweet ID to string with as type. We are converting this actually to the string type. Converted actually. And why we are converting? For further analysis you will get to know why we are converting it. Setting the column in order. Let's set the column in order. Order is not necessary, but for my just convenience, like you can just swap these two, and that's what I'm doing. I'm putting favorite first and tweet count first. Renaming the column names. Why I'm renaming the column names? Because we have to merge two tables on ground of some key values whose name must be common. So that is why I'm converting this ID into tweet ID, because there are actually 3 tables from 3 different sources. So in the first source .csv file we had tweet ID column, right? and this ID and tweet ID is actually the same thing. So that is why I'm renaming it. On grounds of some key, we have to merge them, and that key name should be same, and that is why I'm converting it to tweet ID. Let's check for the head after conversion. Yeah, you can see the ID has been converted to tweet ID. JSON describe, and I also have converted favorite counts to likes and retweet counts to retweets, just for my convenience. That is not recommended, but this one is obviously recommended. Change the tweet ID from number to string for all three, because to merge them we need consistency. So why we are converting all to the string? Because for merging, what happens is that in my first format case, in the first table, we had everything in string. So we need to have string and string merging, not string and character merging. It's better that we have a consistency kind of thing, and that is why we are doing that. So changing the formats, changed it, and now checking it, found out that all are converted to str. Let's combine the data sets. Combine df, JSON and image prediction to Twitter are copy using merge. So I have used the inner join. Inner. Why? Because inner equals to intersection. If you are using outer is for union. We are not doing union here. We are performing intersection. Means whatever is common between both tables, that has to be extracted out. That is why I'm using here inner. Okay. So list of index, join x's are here. So you can find more about inner and outer things here actually. This outer is for union and inner is for intersection. So what was my purpose? My purpose was to get the intersection of data. We are not interested in union of data, because then there would be too many NAs which are not good to handle. So that is why we are using inner. You can use other methods to merge also, like left, right, but I found this one useful, so that's why I'm using it. Now actually I've merged it, and after merging I can see the info here, I can see the head here, and just for the convenience I have renamed them rating numerator to numerator and rating denominator to denominator. Undesired columns, if you want, you can drop them or don't use them. I dropped them. Allow all columns and text to be shown. df merge head. After doing all of this, we have this final thing. We have this final thing. Now we are storing the data. Whatever we did in the upper portion, we are storing it into a new CSV folder. Okay, after merging we are saving it to CSV folder, CSV file. This is our new, we are reading it in the pandas data frame, that is wrangledf.pd.read CSV, this thing. See the head, info. Now we are done with the wrangling thing, and we can do the analysis and visualizations. This lists the dog for rating greater than 2. Okay, so wrangle df log wrangle df rating is greater than 2. This gives us the list of dogs who have rating greater than 2. Rating is actually, I think, 1 to 10. So whosoever gets the rating greater than 2 have been listed here. We are just importing these things. Word cloud and stop words, image color generator. These are I am importing because I want to create a word cloud. And this is PIL, image library. It's not needed in my case, but just I added that maybe I would be performing some image analysis also. Let's define. Now create a function to remove the links and apply it to get cleaner text. Remove HTTP and followed links for better cloud words. Obviously in cloud words we would not want to have HTTP shown. So I have removed that using this diff remove link x dot find wherever there is HTTP. Remove the spaces before the link to end and return that. Remove link is performed. Let's test it. After testing, we see there is no link. Hashtag word clouds of text. Okay, word cloud of text. What I'm doing here is that this is used to collect all the text from column text in DF result. So whatever text in, there's a column named text, and the whole column has to be taken in consideration to form the word clouds. That is why I'm joining everything in the wrangle df.txt into this text one. We are using stop words. You know what are stop words? Let me show you the definition. Stop words are words which are filtered out before or after processing of natural language data. These are usually referring to the most common words in a language. So these are some common words: puppo, puppy, Bruno, dog, good boy, cool, and whatever is related to that, these words, I will generate the cloud word on the basis of that. That's what I have been able to achieve here. Now I was actually trying to mask it off onto the, puppy's footprint. Not able to do it in a very good manner, but still you can try it out. I need to remove this black background. That will look much better actually. But let it be. It looks good here also. You can try and play around with it. I will just put the link in the description box. Now coming to the more part of the visualization. I did some more kind of visualization, and this new master CSV was read by me because everything has been cleaned and in perfect form here. Now converting the columns to their appropriate types and set the timestamp as an index. Obviously columns to their appropriate types and setting time as an index. Okay, we perform this. Okay, dot set index, we converted the timestamp to the index. Describe it. Now we are plotting this retweets and favorite scatter plot. Means what is happening is that number of retweets are increasing and so is the number of favorites is increasing. So you can say that they are linearly correlated, kind of linearly correlated, because you can see it here. It goes like this. As likes increases, so does the retweets. Now we are just plotting here rating plot over time. So as the time changes by, the rating, let's see what is the pattern here. The 0 rating is very less. Most of the ratings are in 12, between 12 and 10 and 12 actually. 10, 11 and 12 is highly rated. So 0, initially there was some zeros, but later on there were very few or even no zeros. But in case of 12 it was a bit diminishing, but in case of 13 you see there has been an increment. So numerator rating 12 is most common if we go date wise plot, obviously. Now we are actually coming on to the text analysis. So I'm using this text blob API. You can learn more about it by googling about it actually. So I have imported that text blob API df text 10. You need to actually install it using pip install text blob. You need to figure it out. I will send I will put the links in the description box about how to install it. In that only we have this sentiment function. So that gives us the polarity and subjectivity of the text 10. This is the text 10 actually. This is Coda. He's a South Australian dex chart, deceptively deadly. This is about there's a review about a dog, and the subjectivity is 0.5, the polarity is minus 0.25. Polarity is kind of negative, deadly, deadly is kind of a negative word. frighteningly majestic, which is frighteningly is a more negative kind of word. Now what I'm doing is that I'm again joining all of that column and trying to find out that whether it has more of a positive comment or more of a negative comment. And after doing more analysis, for a sentiment if greater than 0 we have positive, for sentiment equal to 0 we have neutral, and if otherwise case is negative obviously. Now I've tried to plot, I've style used is white grid. You can use the dark theme also, but white grid suits here. Okay, so what I found out is that the positive, most of the comments were positive, second were neutral, and third is negative. But there is very less difference between the counts of neutral and negative comments. We can infer from here most of the texts are positive, as I said earlier, and secondly neutral and less than 50% in comparison to positive words and negative in polarity. Now we are actually plotting a box plot between dog stages and retweet. I have been able to plot the box. This actually shows that most of the dogs are in puppo category. Most of the dogs are in puppo category. Yeah, because this, you can see the height of the range of it is very much big. But highest retweets are about doggo category. Why? Because the tail can be found here. That's it. Thank you for watching. I would recommend you all to please go through the links in the description box, and if you have any doubts, feel free to comment. Also give me the feedback. This was my first time. Thank you very much.